That's how I remembered to spell business when I was a kid. Busyness. Wednesday. Yep. All right. Quick review. If we have a linear equality with one variable, what's it look like? A linear equality with one variable. What? Yes, it's going to graph as a line. And what would it look like algebraically? No, that's an inequality.
I thought it said equality.
X plus 3 equals 7, right? What's the answer? 4. Is there any other answer other than 4? No. That's a linear equality. What if with one variable? What if I have a linear equality with two variables? What does it look like? X plus 3 equals y. How many solutions does it have? Infinite solutions, but those solutions are limited to what? Being on that line, right? Would 7, 2 work? No, of course not, because 7 plus 3 is 10, and 10 does not equal 2. So everyone's cool with that, yeah? Okay, so what then if I have a linear inequality with one variable? What does it look like? X plus 3 is greater than or equal to 2. How many answers does it have? Infinite. Right? On a graph or on a number line? How would we do that one? Would we use a number line or a graph? We'd use a number line. What if it's a linear inequality? Inequality with two variables. What does it look like? X plus 3 is greater than or equal to? No. Y. Now what's that going to give me? It needs to be a graph. A graph, yes, with X's and Y's. And what must I do on that? There's my graph. Shade one side, right? There's my slope, and there needs to be some shading, yeah? Wherever it may be. In this case, it would be down here, right? And then the last thing we did was quadratic inequalities with one variable. X squared is greater than 0. Right? And then, again, we draw the graph, we shade it, and then we color it in. Or, no, then we only care about x's. Right? That was a bad one. Let's make it x squared minus 1 is greater than 0. So it has to go like that. And where is it greater than 0? Out here and out here. Where is it less than 0? In there. Right? And we only care about the x-axis. Why? Because there's only one variable. Now you notice the title of this section is two variables, correct? All right, so let's do that. So the first thing I want you to do is sketch me that graph. Y equals x squared. That's super easy. That was the very first thing we ever did in quadratics, yes? When x is 0, what's y? 0, 0. And since there's no a's, no stretch factor, no nothing, I go 1 to the right and I go how far up? 1. Then the same on the left. If I go 2 to the right, how far up? 1, 2, 3, 4. Thank you. 1, 2, 3, 4. And it looks like this. Yes? Very first thing we ever did. Right? And we've proved this many times. Pick any points on the graph. When x was 1, y was 1, because 1 squared equals 1. When x was 2, y was 4, because 2 squared equals 4. When x was 3 and 9, when x is 4, y was 16, because 4 squared equals 16. We all know this from our last unit, right? Okay, the only difference now is it's not going to be equals anymore. What do we know about every single point on this curve? Every single point on this curve, right there. It's not on an exact point. What do I know about that x and y? It would have a value, right? Whatever it may be. But if it's on that point, what is its relationship to that equation? Right. Whatever x is, if I square it, it would be y. No matter what, right? That's how these things work. So what can we conclude about the points that lie on the parabola? They are all xy's that satisfy. Remember, that's the proper math word for work in the equation. So they will all satisfy the equality. How many points are on that parabola? Infinite points, right? As long as it's on the graphed line, and I should say curve, on the graphed curve, they will work in the equality. We all know that already, yes? Now, we come to what we have learned this year, this unit. Once we graph that parabola, our Cartesian plane is divided into two regions again, right? Right? Just like with the line. But it's a little weirder because it's a curve, yeah? How would you define those two regions? I'm going to use blue, one above, and I'm going to use yellow, one below. Where do you think the above section is? How would you describe it? What do you feel is above that parabola? Above the vertex? Okay, so that everything up here is above the vertex. Are you happy with that being the answer? I'm guessing. That's a good guess. You're above the vertex. Okay. All right. Are people want to agree? Everyone's happy with that? Okay. If that's the case, then where would you define it as being below? Below the vertex. So this is what Jacob says, and everybody agrees, would be the right answers. Yes? Everyone agree? We don't know. Of course it's a maybe, but that's a fair estimate. Yes? Is everybody cool with this? So how could we check it? Let's do this. Let's read about this first. In which regions do you think this solution lies? Oops. Where would y be less than x squared? Would that be yellow or blue? Yellow. Everybody agree? Everyone agree? Okay, so let's take 4 points from the yellow section and see if it works. So here's my yellow section. Somebody name 4 points. -2, -2. Okay, -2, -2. Let's check. Y is less than x squared. So y in this case is -2 is less than, what's -2 squared? 4. Is -2 less than 4? So are we right with our guess so far? Are we? Sure we are. We shaded over that, and that's part of the solution. Are we okay? All right, so give me another one. Okay, we know that's going to work, right? Okay, so -4, -4. So we're cool. We're good, yeah? Everybody's happy? Yeah? Okay, now, let me posit this question. When we were doing a linear equality, not a parabola, a linear inequality, what did we call the graphed line? Go back 3 pages, 4 pages, wherever it was. A boundary, right? Okay, so have we graphed a line here? We've graphed a curve. Now, when it was a linear equality, it was a boundary, yes? So, does it not make sense that it is a boundary even when it's a curve? So, does that not mean that this graph is important somehow? Well, let's check a point from over here in the blue. Somebody give me a point from in the blue. Let's take this one right here. How's that? 1, 2, 3, 4, 2. Everybody okay with that? So let's check 4, 2. And I'm checking it in y is less than x squared. 2 less than, what's 4 squared? 16. Are we okay? We're cool, right? That's still less. 2 is less than 16. We're still good, yeah? Okay. So now let's take this point right here. That point is 0, 4, yes? Everyone agree? Okay. So we're going to check 0, 4. 4 is less than 0 squared. Is 4 less than 0 squared? No. So what does that tell us about the points inside here? That doesn't work, does it? So while this seemed like a good guess, we have now proved that that's not going to work for us, is it? Because this point is part of the solution. So this point needs to be yellow, doesn't it? So this point needs to be yellow. So what does that suggest maybe about points over here? We could check it though, couldn't we? Let's check with negative 1, 2, 3, 4, negative 4, positive 2. Does that one work? Negative 4, positive 2. 2 is less than 16. Is that true? So we now know that all of this is okay. And we know that this isn't. So that is the above and below. Everybody cool? Now, let me ask you this. What if it was the negative version? Where would the below be? Inside, right? And where would the above be? Outside. It's above or below the actual boundary. Is everybody cool? Okay, now you're intelligent young people. We've proved this. Were we right in our thinking about the solution set? Ish, right? We were ish. So how did we know? Well, we were kind of right because some points worked. How did we define it? Or refine it, sorry. We refined it with what? What did we have to do to refine it and find out what it actually was? Right. We refined it with more test points. And now we've done this one. We've shaded it properly, yes? Now, you're intelligent kids. Where does the greater than lie? In the blue or the yellow? In the blue, right? That's in the blue section. And we would prove that with a couple of test points. We've already done 1, 0, and 4, right? But all the zeros will work, yeah? Because it's y is greater than x squared. So as long as I have x as 0, every y value is going to be greater than 0, isn't it? right? And then just to prove our point, what if I went to there? 1, 6. 1, 6. So y is greater than x squared. Y is what? Is 6 greater than 1? So we're okay. Is everybody good? Did our tables, the table that we just made, because we already used 0, 4 up above, and now we've used 1, 6, did it satisfy? What is the other word we use for satisfy? Did it work here? Yes. And we've already shaded it. What color did we shade it? Blue. Is everybody cool? It's exactly the same as the line, right? We just choose our test points. Y, just like, now what did I just say? It's exactly the same as the line, yes? So why do I need a shaded region? Because what? Right. We need a shaded region. I don't want a highlighter. Because all the points in that region satisfy the inequality. Not just the line. Underline, highlight, do something with the not. Because up until now, we've only cared about the line or the parabola. Make a conjecture. Conjecture is a guess. How do you decide where the solution region is? What's the easiest thing to use? We've done it 4, 8, 9, 10 times already today. What do we use? Test points, right? All we need to do is test points from one of the regions. Now, what do I mean by that? Well, let's draw a sketched parabola, right? There's my sketched parabola. What are the two regions? Inside and outside. Yes? So, if this point satisfies, then that gets the shading. Satisfies, we shade. If it doesn't satisfy, we shade the other region. So we don't need 4 test points. We just need 1. Why did I use 4? Because we were trying to prove how to do the above and below. Everybody cool? All right. So number 11, under what conditions would the graph of the function? Now what does that mean? The graph of the function. Not the graph of the inequality. What is the graph of the function? The actual curve. Under what conditions would the actual graph be part of the solution? What would it have to look like to include this actual line? It would have to have y is greater than or equal to x squared, or y is less than or equal to x squared. It would need those. Then it's going to work. Yeah? So what are the 4 ways we could write this? Y could be greater than x squared. Y could be less than x squared. Y could be greater than or equal to x squared. Y could be less than or equal to x squared. How do I write them? What's my graph going to look like here? Dotted. Where is the greater than? Inside or outside the parabola, for lack of a better word, because above and below was screwing kids up. Where's that going to be? Inside or outside? Greater than? Inside. Or is it outside? Look at how I've written it. What's the way to know? So, what would be a good test point for inside? Right there, yeah? 1, 1. I would use 0, 1. Right? 0, 1. Is 1 greater than 0? So, is this part of the solution? So where do I color? In there. Then this one is where? Out here. Everyone agree? What if, and don't write this down, I just want you to, what if I change the order to this? Well, let's see what happens. What was our first test point? Was 0, 1, yes? 0, 1. Is 0 greater than 1? So if I change this order, what happens to these? They reverse. Does everybody understand? Okay. And then over on this side, solid line, why? Because it's got equals. Greater than is where? In there, and less than is out there. Are we all good? It's exactly the same as the line, yes? All right. There's a graph. Now, it's hard for you guys to see. It probably didn't photocopy very well. This is the shaded area, right? Everyone cool? Okay. So I have 2 questions about this. 1, why is it dotted or dashed or broken? Whatever you want to say. What the shortcut is, the first thing that pops in your head, there's no equal sign there, yes? So it has to be dotted. That's the concrete thing that you're going to say, right? What is the concept behind that, though? Right. The actual coordinates of the boundary function do or do not satisfy the equation. Do not satisfy the inequality. That's question 1. Question 2, why is it shaded? Why is it shaded this way? Why is the shading outside? Okay, so what you're saying, Jacob, the y points have to be less than the line, right? But when you say it that way, I would ask you this question. How can that positive y be less? Do you understand what I'm saying? Like when you're trying to find a shortcut like that, I can poke a hole in your theory, yeah? So now the other thing you may want to say is less than, and you may want to go back to above and below, right? Because if we flatten this parabola down, we've got above and below, easy peasy, yeah? So that's your guess of a shortcut. What's the real reason? Why is it shaded this way? Right. It's shaded this way because all the points in the shaded region satisfy the inequality. And of course, we can prove that by picking any point, like right there. 4, negative 2. Right? Y is less than x squared minus 2x minus 3. Negative 2 is less than, what's 4 squared? 16 minus, what's 2 times 4? 8 minus 3. 16 minus 8 is 8, minus 3 is 5. Is negative 2 less than 5? Yes, so it works. If I do it again up here, which is what kind of blows the idea of our shortcut out of the water, because y is big up here, yes? So let's check that one. That is 6, 3, right? So 3 would have to be less than 6 squared is 36 minus 2 times 6 minus 3. Is 3 less than 36 minus 12 is 24 minus 3 is 21? Is 3 less than 21? So we're still okay. I understand, right? And I'm not trying to put you down. I just want you to see that the real reason. Everybody's cool? All right, let's try and apply it. There's our parabola. Now, something is different here. What is different than all the other parabolas we've done so far right now? It's in vertex form, right? But we still, need to establish what? What's the first thing our graph needs? What was the first thing we established when we had the line? Roots. Okay. Why did we need those roots? That was the boundary line. But why did we only need roots before? Because we were only looking for an x. Does y matter now? So remember when we were doing roots, all we had to remember was it happy or sad, right? We didn't care about the vertex. But now those y values matter, don't they? So now we actually have to establish the boundary line, including what? Including the vertex. So how am I going to do that? We're in vertex form, so it's pretty easy right now, isn't it? What is the vertex? Vertex equals 3, 1. Right? So 1, 2, 3, up 1. Everybody happy with that? So now let's graph it. Can we graph this from the vertex? Where do we go? Right 1 and down 2. Why am I going down 2 instead of down 1? Right. A equals negative 2. So it's a sad parabola that goes over 1 and down 2x squared. Right? Over x and down 2x squared. So then I would go over 2 and down 8, because x squared is 4, but I got to go down 8. 2, 4, 6, 8. And this is what it would look like, yes? Have I graphed it accurately right now? Really? The points are right. What is wrong with the line I've done? It's solid. What does it need to be? Right. Okay. So. Everyone cool? So we've established our boundary. Next, I want to use that point. Where is 2, negative 4? 1, 2, 1, 2, 3, 4. There it is, correct? Everyone agree? So let's check it. B, we've established our boundary line, we've graphed it. Let's check if it's the solution. So I have y is less than negative 2, x minus 3 squared plus 1. Put in what I know. Negative 4 is less than negative 2, 2 minus 3 squared plus 1. What is 2 minus 3? Negative 1. What's negative 1 squared? Positive 1. What's positive 1 times negative 2? What's negative 2 plus 1? Negative 4 less than negative 1. Is that true? Yes, negative 4 is less than negative 1. So that point satisfies my inequality. So what do I need? What do I know now about every point in that region? It will satisfy the equation, or the inequality, yes? So where do I shade? Yeah. Everybody cool? Easy peasy lemon squeezy, yeah? Super easy. It's the exact same thing, except there's a curve now. All right? So you do it. You figure out this one. Go. So maybe we didn't lose everything. Anyway, we should be back. And back we are. Okay. So y equals x minus 2 squared minus 9. What is my vertex? 2 and 2 and negative 9. Once I have my vertex, all I can do is check for stretch factor. Is there one? No. Happy or sad parabola? So over 1, up 1. Now I'm down at negative 9, right? Right? So if I go over 3, 1, 2, 3, I'm going to be up at 0, correct? Yeah? 6 there. And I draw a solid line. Right? Where do I shade? What's your immediate guess? Inside, because it's greater than, right? So your immediate guess is in here. But we're mathematicians. Do we guess when we can prove? What's the easiest number to check? Numbers 0, 0. Is 0 greater than or equal to 0 gone, negative 5? Is 0 greater than or equal to negative 5? So is 0 part of the solution? So I shade where the 0 is. Now technically you might have some teachers that insist you bring this all the way up to the edge of the graph. Am I that teacher? No. Everybody good? Super easy, right? Okay. Go. Step 1, let's get that boundary line. After that, you're working on your own. Except I will remind you that it is solid. Everybody got it? I've recorded all my work. You will notice this time I chose a different way to find the vertex, just in case anybody else did. Everybody good? Easy peasy lemon squeezy, right? Your guess was here, but we did a checkpoint to make sure, right? And of course we do that because we remember things like this. X is greater than 7, and we draw it that way. But if 7 is greater than X, we got to draw it that way, right? So that's why we take a test point, even when we're pretty sure. Okay, let's do a real life one. Because this is the type of thing that people really have to do. So, you guys have all seen this. You guys have all watched sports on TV that are filmed outdoors. You see the guys standing there with the camera, and it's got like an umbrella around the camera, right? That umbrella is a parabola, except it's 360 degrees of parabola. What does that do? It collects the sound. Just like going like this helps you hear things, right? So, I have got a reflector for my microphone. So here's my microphone. It's got a reflector that has a width of 50 and a depth of 15. So in 3 dimensions, we know it would look like, but in 2, it would look like this, right? How far is this? How far is this? 50. How far is this? 15. So now I want to know how much space I can cover, right? Well, we know this is a parabola, yes? So obviously, where's the space the microphone will get? Inside or outside? Inside. I need to know what that space is, because if somebody's outside of that space and I want to hear what they're saying, what do I have to do? I got to move the microphone. Everybody cool? Easy peasy lemon squeezy, right? So step 1, we're going to do this graphically. Where would you say the microphone is if we were on a graph? The origin. Here is our mic, 0, 0, yeah? Right? And we know the mic is going to go like this, yeah? Oops, that was crap. But we know some numbers here, don't we? How far is that? 25. So that point right there has an x value of what? 25. How far is that? So what's that point's y value? What do you automatically know about this point over here then? It's negative 25, 15, correct? Everybody agree? Okay. So where does this mic work? Inside or outside? Inside. Is everybody happy with that? Everybody cool? So what information, talk to your neighbor for a second. I'm going to turn off the screen because, as always, you guys stare at. Okay. Does that tell me what I need to know? You think so? All right. So let me ask you this. Based on that drawing, right now, if I were holding that microphone and Aiden was whispering to Hayden, could I record it? Well, you guys all told me that this graph would solve the problem. Okay, so is Aiden somebody I could record with this microphone right now? Look at Aiden. Is he more than 25 centimeters away from me? Yes or no? Is he more than 15 centimeters away from me? So would my microphone record Aiden right now?
Wait, so you have to like zoom
Would my microphone record Aiden right now?
That goes further than that. That's just how big a reflector is.
I'm asking you that. It's not a semicircle. That region, okay.
That's just the size of the thing, right?
I'm aware of that. Excellent. It goes further, yes. But would it record Aiden? Aiden would have to be in the region, yes? It is going to go on forever, right? Okay, let me change it. Would my microphone, do you think, record you from here? Well, aren't you pretty far out over here? I'm asking you a question.
Yes.
Are you pretty far out over here? How many centimeters do you feel you are away from me? 250 maybe? 2.5 meters? 1? Say 2.5, right? How far are you from me? What do you want to say, 50? This is 50, where my finger is, from me. Maybe 60? 60? So you would be out here at 250, 60. Based on this drawing, would I be able to record you? You think no now, but 2 seconds ago you said yes. So I'm going to ask again, is the graph the good way to handle it? No, right? Can we solve it algebraically? Okay, so what would happen if we did this algebraically? Do we have a vertex and one other point? Y equals what? In vertex form, x minus p squared plus q, yeah? Do we know our vertex? What is it? 0, 0. So it's y equals a x squared, because it's 0, right? Ax squared. Ax squared. And then it's another 0, yes? Everyone agree? So it's just ax squared. Do we know any points? Yeah, we know 2 points. We know 25 and 15, correct? Right? So where does that 15 go? 15 equals a. What's the x? 25 squared is 625, yeah? 625. A, how would we solve for a? Divide, and 15 and 625 gets me divided by 5, 3 and 125. So y equals 3, 125th x squared, right? Everybody cool? Now, we know that we need the greater than there, don't we? Because we need to be inside that whole region. As Jacob says, that region goes on forever, so I need to be greater than that. So if this is my boundary, what do I need this to be? Instead of an equal sign, what does it need to be? Y is greater than 3 125ths x squared. So now, can we tell definitively if my mic will pick up Jacob? How? Where is Jacob? We said Jacob was 250 and 60, right? So what would go here? 60 greater than 3 over 125 times x squared. Well, x squared is 250 squared. That's a big number, yeah? So get your calculator out, find out. Now multiply that by 3 and divide it by 125. Is 60 greater than 1,500? So could I record Jacob? No. Could I record Aiden? Let's find out, shall we? Momoka, take the end of this. Keep pulling until it's at Aiden's mouth. Well, is that about where your mouth would be? Little more? Right there? Okay, 10 feet is 330 centimeters. Right? So what is the y value with Aiden? 300. So Aiden's y value is 330, right? What's Aiden's this way? We'll just go to Ashton. Take that over to your mouth. Not just, no, doofus, flat. It's x and y. Right there. Which is 7 feet, which is 84 times 2.5. Quick, 84 times 2.5. 82 will be fine. Is what? 205. So that's our new x and y, right? So y has to be greater than 3 over 125 x squared. Y is 330. 3 over 125 times 205 squared. What's 205 squared? 42,025 times 3 divided by 125. Is 330 greater than 1,008? Did we do yours backwards? No, he's way further away than you. His x. Your x was 250, and you were this close. His x was 205. It's that far away. So will I even get Aiden? Is that in the solution region? No. Everybody understand? The graph works for 25 centimeters on either side right here to 15 centimeters, right where this is from my mouth. Right? So it doesn't really help us. But in algebra, we can really do it. Okay, let's turn the page over. Now, there's some printing issues here. Right here. That should say M is less than or equal to 1450 d squared. That's what that should say. Right? So my mass has to be less than this. I want you to tell me how I can relate that mass to the rope. If I was going to do a graph, is that particularly easy to graph? If there's no mass, then what diameter of rope do I need? Nothing. 0, 0, right? When I go over 1, how far up do I need to go? So I'm going to have 1, 1450, negative 1, 1450, correct? When I go over 2, I should go up 4, right? But I got to go up 1450 times 4. What's 1450 times 4? So I've got another point at 2, 5,800, and another point at negative 2, 5,800. Is that a particularly useful way to solve how thick a piece of rope I need? Not really, because it's the same thing we just did, right? I mean, it's easy to graph. Solid line. Yeah? Where would it be? Less than, so where would it be? Out here. Right? Do I need negatives? No, because they're exactly the same, yeah? So I got to be somewhere out here. Easy peasy, right? You've already solved it. Is 0, 0 an allowable checkpoint? No, because it's on the line. We know it'll work. You'd have to choose a different one. So let me ask you this. My mass, if I had a rope 2 centimeters or 2 inches, what's the mass I could hold? Where would I go? Would I go out to or up to? My rope is 2 inches wide. Diameter is 2 inches. Is the diameter on the X or is it on the Y? X, so I would go out to here and have 2, correct? Where would that go in this equation? D. So M would have to be less than or equal to 1450 times 4, yeah? What is 1450 times 4? So my mass would have to be less than or equal to 5,800. Easy peasy, right? And this makes sense, doesn't it? As the rope gets thicker and thicker, I can hold more and more mass. If the rope is thin, I can't hold much mass. Everybody cool? Now, obviously, if I'm rock climbing, 5,800, it's a lot of pounds, right? Because it's pounds, isn't it? No, it could pull me up. That's my point, right?
How would you get up with 5,800?
But no, that's not the question. The question is it'll hold 5,800. But my rope would be 2 inches in diameter. That's 2 inches. How much space would that take up if I was rolling it up? Could I rock climb with it? Like if I wanted to climb up 500 feet of rock and my rope was that thick, that's not realistic, is it? I want the thinnest rope possible, yes?
What we're going to do is, since the rope will weigh a lot, we're going to bring 2 ropes so we can rappel down with 1 rope with the other rope in our backpack.
Or we could just understand the math I'm trying to do here, right? I know my mass, so now I know the thickness of rope I need to do what I need to do. That's the point of the math, not the way to get around the math. I'm going to bring 17 ropes, then I'll be okay. Garumph. All right, what are our key points now that we're on 2 variables? Are all of our other key points still solution region? Or wait. Two regions. 1, 2. Solution lies in one of those. Point 2. Vertex matters now. Since its y is greater than x squared, y values matter. 3. Y is greater than x squared, has dotted. Y is greater than or equal to x squared, has that. In this one, does the parabola work? Does the parabola count or not count here? Parabola doesn't count. And here the parabola does count. And lastly, and I'm going to repeat this one, even though it's a key point we already know and we've written it 3 times. Most of these are new points, right? This one I'm going to repeat. Test points for shading. Because if we mix up the order or if we switch the A, you can you won't always, but you can find yourself to be confused, yes? So we always use a test point. Everybody cool? And the test point either satisfies, and then we shade over it. We shade its region. Or it doesn't satisfy, so what do? Which do we shade? We shade the other region. Other region. Is everybody good? Excellent. So you're going to do page 153, 154, 155 is the answer, wasn't it? No. What is 155? What do I want you to do on 155? I got to check what the instructions are of 155 because I appear to have cut them off when I was copying it. So you're going to do 154 to 157, 58. It looks like a lot of work, but there's a lot of pictures, and I left a lot of space to do work. That's today. Tomorrow and the next day, we will be doing the review and marking it. We will test on inequalities Friday. I know I don't like to do test Friday, but we're coming up to Christmas, and I know, as I've been teaching for 21 years now, the last week before Christmas is a write-off. I also know that one of the first weeks back will be snowball, and you will all be bitching endlessly to go watch basketball games, to which I'm going to say no. I am warning you now. I always say no, because simply put, if the basketball game ends at 2:25, amazingly, it was so important to go, but as soon as that bell rings, nobody wants to be there. So, obviously, you're just trying to get out of class. So, warning now, if you wish to go see a snowball game, you are going to be, don't bother showing up, because I'm not letting you go. And then, but that does cost us a week of school. So, I still got to get through rational expressions, trig, finances. Oops. And grade 11 trig, unless you were in honors 10, grade 11 trig is going to be very difficult. No. Trig identities? No. Okay, so go. But I have to